everyone, I hope you are doing well. So today class will be continue what we learned in previous class about transport system. So same things, if you have any comments or suggestion, don't hesitate to comment below. I will check it out later. Okay? So before we start, ta-da! It's grandmother story time. Okay, in our last class, there's a comments asking about how to learn biology better. So I've been few days looking through how we can learn things better. Okay, there's one thing I found an inspiring essay in the apps called Medium, which embarked me what I want to tell you today. Okay, so how to learn things faster, effectively, and also efficiency. So the things you can replace it with any subject like biology or sejarah, anything. Okay, how to learn them in a faster way, in an effective way, and efficiency way. Okay, so here in his essay, there's a two guys that's been mentioned about. Um, so let's see. Okay, who are they? Who are they? Okay, let me give you some clues. Both of them are scientists and they are really, really famous. And both of them are also the Nobel Prize winner. Okay, you get it? Who are they? Yes, the first guy is Albert Einstein, and the second guy is Richard Feynman. So, their study style is basically very unique. Okay, Albert Einstein is a Nobel Prize winner for 1921, or on the other hand, Richard Feynman won Nobel Prize in 1965. Okay, both of them are very, very professional in their own field. So let's see what is their unique learning style. Yeah? So for Einstein, he think that learn to enjoy the learning process. Okay. Okay, learn to enjoy the learning process. Okay, he thinks that happy learners are the quick learners. So before you start learning your biology, okay, you have to love it. Then you start learning it and you enjoy the learning process. Then only you can master it. So how about Richard Feynman? Richard Feynman thinks that teaching other is the best way of learning. Okay, why? Okay, so what he means is when you learn something, you have to go through your brain, you have to digest it. Then later on, you explain it to your friends, your maybe, yeah, your friends in your class about transport system, for example. So your brain will start to digest it before you explain it to others. So, okay, so when you share something with your friends, you will better remember them. Okay, so you will later on get double of your outcome. Compare that when you just read on your own. Okay, so by combining both of their learning style, okay, you have to first love your biology, then you learn it, then you digest it, you enjoy your learning process, then later on you teach others. Okay, then only you can master them. Okay, then mother story time, and so we'll be now continue with Form 5 Chapter 1 Transport, what we continue in our last class. Okay, so the second learning outcome will be continue with synthesizing the concept of circulatory system. So who is the one that forces your heart to contract? Who? The cardiac muscle. The cardiac muscle is a muscle that surrounding your heart. It is a strong muscle and is interconnected. Okay, as you can see here, they are interconnected. Okay, they are also myogenic. Okay, what's the meaning of myogenic? Myogenic is a contraction which carry out automatically, contract and relax automatically where your nerve impulse doesn't include, which means your brain cannot control your heart to pump. Okay, you get it? Okay, so next, sinoatrial node, which is also known as the pacemaker, and atrioventricular node, which is also known as AV node. Okay, as you can see here, is where they're located. Okay, the SA node, the AV node. Okay, remember where's the bundle of this, and also remember where's the Purkinje fiber. Okay, so we'll be looking through the processes how your heart pumps. Okay, so first, the sinoatrial node will generate the nerve impulse because it's the pacemaker, right? To initiate the contraction of your heart muscle. Then your atria start to contract. Okay, then your blood will flow in through your ventricle. Then your electrical impulses will be reach your atrioventricular nodes and pass through your ventricle. Okay, then the bundle of his fiber will conduct your impulse through the apex of your heart. Okay. Then later on, the Purkinje fiber, which is all the small nerve impulses here, okay, they will travel through your ventricles upwards and cause your ventricle to contract. Okay. So let's see this video. Okay, this is how your heart pump and your blood flow. Okay. So next, what is the cardiac cycle? So cardiac cycle is a series of events that occur during one complete heartbeat. Okay? Okay. Systole. Systole is basically the contraction. It happens during the contraction of your heart where the highest pressure is. And diastole is the otherwise. Periods of relaxation of your heart when your heart is filled with your blood. Okay. This is the summary of your phases of the cardiac cycle. Okay, as you can see here, they show you where your blood will be flowing, and the ECG, which is also known as electrocardiography here, and they tell you when your atria is contract, when your ventricular is relaxed. Okay, so first thing first, we look at here. Okay, so atrial systole, which means the contraction process. Atrial contract and your blood will flow into ventricles. Okay, then later on your ventricle will start having a higher pressure. Then later on your ventricle contraction, because of the impulses has been traveled through your apex of your heart. Okay, so your ventricular start to contract and your tricuspid and bicuspid valve will be closed. Okay, then later on, when your ventricular start to contract, you will force your blood flow out of your heart. Okay, then your semilunar valve will be open. Okay, next, when your ventricular start to relax and your atrium also start to relax, and your blood will start filling up your atrium here. Okay, so this is all the series. You see how when you're in the hospital and you look at this ECG. Okay, how your what will happen when your atrial is contract, what will happen when your ventricular is contract. Yeah, okay, so remember this diagram and you can answer your essay better. Okay, so how your blood travel throughout your body. How? So first, the pumping of your heart that create a pressure of it. So as you can see here, when your ventricle contract, then your blood flow and come out with a systolic pressure. Okay. Next, the contraction and relaxation of your skeletal muscle. Okay, as you can see here, the skeletal muscle is located around your brains. Yeah, here. So when your muscle starts to contract, you can see here your lumen of your blood vessel, your veins become smaller, so create a higher pressure for it. And your valve helping you to ensure your blood is flow only in one direction. Okay, you get it, right? Okay, so blood pressure. So Blood pressure is a pressure that exerted by the blood on the walls of your blood vessel. So the blood pressure in arteries are usually higher than those in the veins. So higher blood pressure usually occurs in systole stage, which is the stage that your heart pump blood. Okay? Normal human blood pressure usually between 120 and 80 millimeter of mercury. Okay? The regulator of your blood pressure is by your baroreceptor. We will be talking it later in your aorta and also carotid artery. So when your heart rate will increase, when you see your crush? No. Okay, heart rate increase is due to three factors. So first, increased secretion of hormones such as adrenaline. And next, high concentration of your carbon dioxide in your blood, which heart rate will be increased so that your blood will oxygenated blood will be pumping throughout your body, okay, so that the gases exchange can be occurs between your body cells. Okay, next, when your body temperature is elevated. Okay. Regulatory mechanism of blood pressure. So what is baroreceptor? So baroreceptor is a receptor that monitor your blood pressure that flowing through your body and your brain. So it is located at the wall, as you can see here. It's located in the aorta and also your carotid artery. Okay, carotid artery. What is carotid artery? Carotid artery are the major blood vessels that in the neck that supply your blood to your brain, neck, and also your face. Okay, so you want to know where is your carotid artery, you can basically touch your neck. It's somewhere that you usually find your pulse. Okay, when you touch here, okay, you can feel that your pumping of your heart. Yeah, that's basically your carotid artery is located. Okay, so next we'll be talking about the negative feedback mechanism of your blood pressure. Okay, it will involve the increase of your blood pressure and the decrease of your blood pressure. So what will be happening in your body when your blood pressure is abnormal? Okay, so when your blood pressure increase, what will be happen? Okay, after your physical exercise, when your blood pressure increase. Okay, so your baroreceptor in your aorta and your carotid artery will be stimulated. Okay, then it will send nerve impulses to your medulla oblongata in your brain. Okay, then the medulla oblongata will send the nerve impulses to your effector. So then carry this list of action of effectors. So first, weaken your cardiac muscle contraction because your blood pressure is too high. So you will lower down your heartbeat rate so that your heart won't be pumping too much blood out. Okay, the smooth muscle will be relaxed. Relaxed means your lumen will become bigger, so it reduces the resistance of your blood flow through your blood vessel. So it's called vasodilation. Okay, how about the when it happen in blood pressure decrease? It's basically the opposite things of the blood pressure increase. Okay, when your blood pressure decrease, it happens when you are in a state of shock. Okay, when you look at your bill, it's like $100 million your electrical bill. Oh my god! So you have in a state of shock. So your baroreceptor will be immediately stimulated, okay, when your blood pressure decrease, and it will send nerve impulse again to your medulla oblongata in your brain, okay. Then the nerve impulse will send to effector and carry out the list of action. Okay, first, it will stronger your cardiac muscle contraction, so your heart will be pumping strong. Okay, increase your heartbeat rate, and your muscle in your artery will contract. Okay, so that increase the resistance of your blood flow through your blood vessel. It's called vasoconstrictions. Okay, this basically you have to remember just one either the blood pressure decrease or the blood pressure increase. Okay, remember one, then if happen the opposite one, then you can just, you know. So next we'll be talking about what is the pulmonary circulation and the systemic circulation. Okay, so let's see what's the other difference. Okay, so pulmonary circulation is it happens when the blood moves between the heart and also the lungs. Okay, it helps you to transport the deoxygenated blood to the lungs so that you can absorb your oxygen and release the carbon dioxide. On the other hand, systemic circulation is happen when the blood moves between the heart and the rest of the body. So your oxygenated blood can be delivered to your body cells and you will carry all your deoxygenated blood back to your heart. You can see here. So the horizontal one is your pulmonary circulation. Pulmo in Latin means lungs. Okay, and this one means the other systemic circulation. Okay, of your blood. Okay, next. So there is basically two types of circulatory system: the open circulatory system and the closed circulatory system. So open circulatory system occurs only in invertebrate. Invertebrate have one or more hearts. Okay, it also has a network of vessels, and the hemocoel is present. So how about closed circulatory system? It only happened in vertebrate and it only had one heart. Okay, one heart, and open circulatory system have one or more hearts, remember. Okay, then the closed circulatory system can be classified further into single and also double circulatory system. Okay, so we now look at the open circulatory system in grasshopper. So grasshopper has one or more heart to pump hemolymph. Remember hemolymph? The terms that we learned last week is that yellowish, greenish, colorless liquid, which also is somehow like blood in grasshopper. So it will pump the hemolymph through the vessels into the hemocoel. Hemocoel is the empty space that carry your hemolymph. Okay, so hemocoel contains soft internal organ and is usually filled with hemolymph. Okay, then the chemical exchange will be happen there. Okay, the oxygen will be exchanged out and the carbon dioxide will be taken out. Okay, so when the heart relax, the hemolymph will then flow back to your ostia. Ostia is the pole of the heart. You can see here. Okay, it's the tubular heart. One heart, two heart, three heart, four heart, five heart, and the ostia is the pole of the heart. Okay, ostia usually have walls with it will be closed when your heart contracts, just like what happening in human heart. So closed circulatory system, remember, can be classified into single and also double circulatory system. So single circulatory system can only happen in fish. It only has one atrium and also one ventricle. It's a one circuit of blood flow. Okay, it's only one round. Okay, the blood will only flow into the heart of the fish once. Okay. Okay, so for double circulatory system is further divided into incomplete double circulatory system and also complete double circulatory system. Incomplete double circulatory system will happen in amphibians and reptiles. They have three chamber hearts with two atrium and one ventricles, and the blood will flow to the heart twice. But why it's called incomplete is because there's a mix of oxygenated blood and deoxygenated blood. We will look it later. So the complete double circulatory system happens in birds, mammals, and also humans. Okay, it has four chamber heart. We have two atrium and also two ventricle. Okay, the blood will flow into the heart twice, just like what happened in incomplete. But the oxygenated blood and deoxygenated blood is separated here. Okay, so let us look at what happen in single circulatory system. So, single circulatory system, the blood will flow from the ventricles. You see here, this is the ventricle of the heart. Will flow from the ventricle to your bigger capillaries, just like the lungs in humans. But this use is the respiratory system in fish. Okay, few capillaries converge into a vessel, then that carry all the oxygenated blood to your blood capillaries, and directly they will flow through your systemic circulation. See, it didn't flow back to your heart. And the deoxygenated blood will later follow the veins and back to the atrium of the heart. Okay, as you can see here, it's just a one flow system. Okay, so how about incomplete double circulatory system in amphibian and reptiles? So first thing first, we have to remember the terms pulmocutaneous circuit. So pulmo is a Latin word, means the lungs. Okay, cutaneous is an English word which means the skin. Okay, so as you know, amphibian is actually can be breathed through the skin and also the lungs. Yeah. So in incomplete double circulatory system, they usually have three-chamber heart, which has two atria here and only one ventricle. As you can see here, there's a mix of the oxygenated blood and deoxygenated blood here. Okay. So the deoxygenated blood will follow the veins and enter your right atrium, then followed by right ventricle. Then after contract, it will go through the pulmocutaneous circuit. Okay. Then later on, the oxygenated blood will flow back to the heart before it goes to the systemic capillaries. Okay. So as you can see, yeah, it's a proof. It's a mix of oxygenated blood and also the deoxygenated blood. Okay. How about the complete double circulatory system? Okay, you can see here, there's a spectrum that separated all your oxygenated blood and deoxygenated blood. Okay, this complete double circulatory system gives you the efficient and also rapid delivery of high oxygenated blood to the organs of your body. So your right ventricle will pump your blood to your pulmonary circuit, okay, which undergo your gases exchange, and your oxygenated blood will later flow back to your heart and then later pump out to your organs, and your deoxygenated blood will then flow back to your heart. Okay, just simple as that. Remember, there are differences. Okay, so we come with learning outcome 3. Okay, we might going to take a 2-minute break before we continue with mechanism of blood clotting. Okay, so take a break. So if you have any question, you can ask now. Okay, I'll be answering. So the Hisham tell me hi. Hi. Okay, 2-minute breaks, eh? Okay, relax yourself and get ready for the third learning outcome in transport system. Okay, can we continue? Okay, our next learning outcome is to understand the mechanism of your blood clotting. So what happens when you're having a wound on your skin? So blood clotting, why we need blood clotting? So first, we have to prevent serious blood loss in your blood vessel, okay? And to maintain your blood pressure, because if you have a wound on your blood vessel, have a blockage of your blood vessel, your blood pressure will be having affected. Okay. Next, also to maintain your circulation of blood in closed circulatory system. Okay. So next, prevent entry of the foreign substances and microorganisms into your body through your damaged blood vessel. Okay, so if there is no blood clotting happens and the foreign substance and also microorganism get into your body, then you will get sick. So what also these are the terms that you need to remember before we start the mechanism. Okay, so first the thromboplastin, which usually found in platelets. Okay, platelets, remember what is platelet? Okay, and next prothrombin, inactive plasma protein. Okay, it will later be converted into thrombin, which is the active plasma protein that acts as enzyme. And this thrombin will later triggers the conversion of fibrinogen, the soluble protein, into ribin, the insoluble protein that cover up your wounds. Here, yeah, this is the mesh of wire, the threads that cover your wounds. So let's look at this picture. So if you're having a not really severe injured, so it will only go through this process at the top of your picture. So if you have a severe wound or injury, your body will come up with all these sequence. Okay, so first, if your blood vessel is damaged, okay, your connective tissue of your blood vessel will be exposed to the external environment. So if you have cut, okay, your blood vessel will expose, so your blood will be loose. So the platelets will then stick together. You can see here, stick together and hit, so they can block out your wound. Okay. So the aggregation of these platelets will form the plaque. It's known as plaque. Okay. This plaque can stop your blood loss. Is what I told you late just now. And if your damage is severe, where your plaque cannot stop your blood loss, so your platelets, your damaged cells, and also the clotting factors, they will all come together and form thromboplastin. That's what we learned just now, thromboplastin. And the thromboplastin together with the calcium ion, you see here, calcium ion and vitamin K will later convert your prothrombin into thrombin. Okay, the active enzyme. Okay, thrombin will you then catalyze the reaction that convert your fibrinogen into fibrin. Then this insoluble protein will then cover up your wounds so that it's block the blood loss. Okay, and after the fibrin is hardening, okay, it will form a scrub. It's the things that you like to peel off after you have your wound cover. So don't go and peel off it. Okay, it's basically the protection layer of your wounds. Okay, you get it? So what happens if your blood clotting having a problem? So first there will be two disease. So first one, the hemophilia. Hemophilia is a hereditary illness. What's the meaning of hereditary? Hereditary means if your grandmother, and then got this disease, you probably will have the same disease. Okay? So when you have baby later, if you got hemophilia, then your baby will also get hemophilia. Okay? So this disease is caused by lacking of clotting factors. Remember what clotting factors? The vitamin K. Okay? They're needed for your blood clotting. Okay? So this impairs ability of your blood to control your bleeding, and you keep losing your blood, and the scalp, remember the things you want to peel, will not form. Okay? The vessel, see, will continue blood excessively, and this bleeding can eventually lead to death. You can probably die from this disease because your blood couldn't stop. So be careful, yeah. So thrombophilia. What's thrombophilia? Thrombophilia is basically the opposite of hemophilia. It's caused by the defect in blood vessel wall. Okay, impair or blood clotting factors. Just now it's like the blood clotting factor cannot form, but here it's over. Blood clotting is overreaction. Okay, this is caused by the mutation of the prothrombin. Okay, so you can see here in the picture, it will start aggregate everything and form blood clots. The blood clots in your vessel is basically very dangerous. Why? Because it will reduce your blood flow through your vessel and increase your blood pressure inside your vessel. Okay, so if this clot happen in coronary artery, you know where it is. Coronary artery is the arteries that blood vessel that send your oxygenated blood to your parts. Okay, if this artery is blocked, okay, your cardiac tissue will no longer receive oxygenated blood and your your cardiac tissue will die. Okay, your heart couldn't pump anymore. So, it's very dangerous, right? Okay, so here is some terms that you have to know. Thrombosis is a clot formation in an unbroken vessel. As you can see here, there's no, but it starts forming the clots. So this situation is called thrombosis. And thrombus basically means the blood clots. So these blood clots can be known as thrombus. Okay, if these blood clots start to move, okay, it's known as embolus. Okay, you get it? So next, very fast, huh? We came into the learning outcome 4, synthesizing the concept of lymphatic system. Okay, so what is lymphatic system? Lymphatic system is actually very important, because it's help to prevent you from sickness. Okay, so first we need to learn about the interstitial fluid. So what is interstitial fluid? Be careful of the spelling of your interstitial fluid. Don't mess up with intestinal. Okay, it's different. Intestinal is your digestive system, but interstitial fluids is everywhere in your body. Okay, so interstitial fluid is a thin layer of fluid which surrounds your body cells. And the blood come with all the very high hydrostatic pressure, and your osmotic pressure is created between your capillaries and surrounding tissue, which is outside your blood vessel. Okay, osmotic pressure. Usually the hydrostatic pressure is higher than the osmotic pressure, so that your substances can be filtration out from your blood vessel. Okay, these contain the water, dissolved nutrients, hormones, all come out from your blood vessel so that your body cells can be accepted. Okay, so next, what is the importance of your interstitial fluid? Okay, if you imagine if you don't have interstitial fluid, what will be happening? So they basically, the interstitial fluid fill up all your gaps with cells. If your cells don't have gap, it can't be as can't become bigger, become smaller. So it cannot like having a flexible area for them. You also don't like your friends to be very close near to you, right? Same with cells. Okay, next. The interstitial fluids also act as a medium of diffusions of nutrients and also waste products. Okay, it provides an optimal environment for your cells, so you feel heat out of your body, and you won't die. The cells won't directly feel the heat. Okay, because there is an optimal environment provided by interstitial fluid. Okay, the interstitial fluid usually maintained in pH 7 and 37 degrees Celsius. Okay, so your cell will be safe. So what is the fate of your interstitial fluid? So your interstitial fluid sometimes will be too much or just less. Okay, so what happens if your interstitial fluid is too much? So first, 90% of this fluid will be diffused back to your blood capillaries, while the other 10% will be diffused into your lymphatic system. Here comes lymphatic system and your circulatory system, the relationship. Okay, so the interstitial fluid help you to maintain the normal blood volume. Okay, if your blood volume is too low, the interstitial fluid will go in. Yeah. So before we start with the mechanism and everything in lymphatic system. First thing first, we have to know all the components. Okay, remember the terms, yeah. So lymph capillary that run through your body. Okay, and the lymph vessel is here, a label lymph vessel. Okay, lymph nodes. Lymph nodes is basically all the big dot in your body that will help you to produce your lymphocyte. Remember the agranulocyte and granulocyte? Remember? Never eat banana like monkey. Okay, so next, thymus. Thymus is an organ, yeah? Organs here, located here. Okay, next, the spleen. Remember spleen? Place where all your red blood cell and white blood cell being destroyed is in your spleen. Okay, the right lymphatic duct and also the thoracic duct. Okay, what is the importance of your lymphatic system? What is important? So first, it helps you to remove all the excess interstitial fluid back to your circulatory system. Okay, to maintain your blood volume, right? So it also helps you to absorb and transport your lipid, glycerol, fat-soluble vitamins such as vitamin A and vitamin K in your digestive system. So as you can see here, this is where your intestine, okay, it's come out in your intestine, right? Come out all the villi that help you to take up all your fat-soluble things that cannot be taken up to your blood vessel, okay, because it's too big and it's fat soluble. So lymphatic system will take all of them, okay. So that will all gone, all the substance will go. Substance that can be water soluble will go into your blood capillaries, or those cannot, those are fat soluble will go into this, the lymphatic vessel, okay. So next, it also plays an important role in your immune system by producing your lymphocyte. Remember, never eat banana like monkey. Remember that? So next, help you also to transport your water, your hormones, your glucose, everything. Okay, remember the four importance of lymphatic system. Okay, so next, lymph flow. You're wondering how your lymph flows. So first thing first is don't have heart to help you to pump your lymph. So it helps with your first valve. Okay, just like what happened in veins. We have valve and it also help by muscular contraction that contract so your lumen of your vessel is smaller, create a pressure that pump out. Okay, and also the interstitial movement, the peristalsis movement is this one. Okay, so peristalsis movement is basically involuntary action that cannot be controlled by your brains. Okay, it also helps in your helps to like travel your lymph flow. Okay, when it's contract, then your thing will flow downwards, downwards, downwards. Okay, so the pressure of your inhalation and exhalation also help your lymph flow. So, okay. So what are the relationship complements with your lymphatic and circulatory system? Okay. Remember, they are interconnected. You can't have only your circulatory system without your lymphatic system. You can't have only your lymphatic system without your circulatory system. Both are very, very important. Okay, therefore they are interconnected. Okay, so these fluids, the lymphatic system will help you to return your fluid back to your circulatory system. Okay, It has the lymph. Okay, lymph from your interstitial fluid will go into your lymphatic capillaries and form lymphs. And this lymph will flow to your lymphatic capillaries, go through your lymphatic vessel, then will come in across with your lymph nodes. Okay, lymph nodes. Then it will go through back your lymphatic vessels and go to your thoracic duct and also right lymphatic duct. These are the two major ducts that you have to remember. It's connected all the vessel, all your lymph to the big vessel, the thoracic duct and also the right lymphatic duct. Then your thoracic duct will carry all the lymph to your left subclavian veins, while your right lymphatic duct will carry all your lymph to your right subclavian vein. Okay, later on, these both veins will carry all your lymph, your fluid back to your blood. Okay, so right lymphatic duct, just now we mentioned that, right? Right lymphatic duct and also the thoracic duct. Okay, they have two different places that take up all your limbs. The responsible, okay. So right lymphatic duct will be responsible to receive all your limbs from your, see here, right arms, your shoulder, right shoulder, and right side of your head, and also the neck. Okay. While the thoracic duct will receive all your limbs from your left of the head, your neck, your chest, your left limbs, and also the entire body below your ribs. You know where your ribs is? Yeah, basically it's on your chest area. So they are responsible in two different areas. Okay, they will take up all your lymph, then from your lymphatic vessel, remember, then flow it back to your circulatory system. So what happens if your interstitial fluid fail to return to your circulatory system? Okay. Why? What happened? Okay, as you can see here, if your interstitial fluid will fail back to your circulatory system, the oedema will happen. You can see here, your food will start to swallow. Okay, so here, see? Blood tissue will start to swollen, and the excessive accumulation of this interstitial fluid in the space between the cells will cause the happening of oedema. Oedema is too many interstitial fluid inside your food. Okay, it can be very dangerous. Yeah. So it may cause by the block of your lymphatic vessel. So this edema, maybe the lymphatic vessel in your food is being blocked. Okay, so your interstitial fluid cannot be flow back to your lymphatic system. Then they all aggregate in your food. So this situation is prolonged, it will cause your skin to swell and also stretch. This will cause the damage of your connective tissue under your skin. And later, if your skin start hardening and you feel like, oh, difficult to walk lah. Right? Okay? So remember that if your interstitial fluid fail to return, it will cause you oedema. Okay. So here come with the essay questions. There's a full essay question here. So first, compare and contrast between blood, interstitial fluid, and also your lymph. Remember? So maybe you can say I'll give you some clue, okay? So blood it has hemoglobin. Hemoglobin can only happen in blood but not interstitial fluid and lymph. Okay, so you can draw like a graph for yourself. Okay, you compare and contrast between this blood, interstitial fluid, and also your lymph. So next, the second question, you need to explain to me how your lymphatic system complement with your circulatory system. Remember the interstitial fluid, the excess lymphatic interstitial fluid flow back to your lymphatic system, then flow back to your circulatory system to maintain your blood volume. Okay, so third one, Similarities and differences between circulatory system and lymphatic system. Okay, you have to compare and contrast between your circulatory system, those involve blood, the everything. Then your lymphatic system, what's the color between them, their medium. Okay, so you have to come out with a list. Okay, try to give as much as possible, and I will provide you the answer later. Yeah, so you can also briefly describe on how your fluid enters, your interstitial fluid enters and also leave your lymphatic system. Okay, it's a list of action, list of process on how your fluid enters and also leaves your lymphatic system. So you try to answer these four essay questions, and later on I will be giving you the answer next week. Okay, in our next class. Okay, so in our next class, we'll be talking about understanding the role of the circulatory system in blood defense mechanism. There will be first line of your defense mechanism, second line, and also third line. We'll be talking about that later on. Okay, in our next class. So second, you will be learn to appreciate a healthy cardiovascular system because I will be telling you all the disease regarding your hearts and everything so that you will start appreciate, oh, thank God, I got a very, very healthy cardiovascular system. Okay, then you will start work out and having a good sleep. Okay, so third one, we'll be discussing about the transport system in plants. Remember the xylem and also the phloem. Okay, so stay tuned next class. So I am Miss Lau, and if you have any inquiries or any problems, you can email me. Okay, maybe anything that you want to know about how to learn biology in a more effective way, how you learn something, how you memorize all the terms, and you can email me or also comments below, and I will check it out later. Okay, so this is my email. Okay, so again, if you like the grandmother story section, any comments below, or you would like more information outside of your syllabus, you also let me know. Comments below. Okay, again, comments below so that I will know it and I can prepare all the things later in our next class. Okay, thanks for watching. So now we're looking through. Is there any comments? Well, maybe today's class is a bit hectic. So there's haven't been any comments here. So, so if you have any question, you can start asking, okay, below in the video so that I can check it out. Yeah, so there's a few hi. Yeah, Fatin, if you are here again, hi. So yeah, any question regarding biology? Maybe you can ask me about something about your form 4 biology, also acceptable. If I can answer all your questions, I will be answer either in our next class or yeah, in our video. I'm preparing in our video or I will comment in the video below. Okay. Oh, so one thing, your essay answer for your last class. Remember, we have an essay question, 3 essay question in our last class. So if you're interested in the answer, you can check on your previous video. Okay, I have post the answer at the comments column. Okay, so later on, check it out. Okay. So I think it's basically the end of the class. So I'm still waiting for your comments. So let's see. Let me refresh my portal so that I can look through your questions. Okay, bye-bye.